So let's land on a planet where is no climate change, where there's still some snow in the woods in the winter. And so this is an incredible journey on catching random Korma timeouts, which were not that random actually. So that was really boring thing that we experienced at our beamlines at Petra for several years, and it was basically a timeout, which was quite random, but it's really occurred every run. So, for instance, if you run in a loop, I don't know, 1 million requests, then somewhat on the 300K request or 500K request, it definitely will fail with the timeout. And it was really easy to prove that it's not a client-side problem, it was a server-side problem. So since we are dealing with Java, usually the first suspect is garbage collector. So I made some investigations, and basically the garbage collector gives the maximum pause of 10 milliseconds. So that's really not that problem. So then I was thinking about investigating the jack orb, but if you just enable the debug logger mode in the jack orb, it's not very useful. It just gives you some information like operation started, post, invoke, and then boom, at some point you have an exception. Not that useful. But we have to praise open source software, because in this case we can download latest version of the source code, insert logger, then insert even more logger, and then insert even more logger. And finally, we can trace it down. So here you can see there is a 5-second delay on a single request. So it's like it's created in a request processor number 5 thread. Then it does something, and then boom, 6 seconds, 11 seconds. So 5 seconds delay. So that's really more than standard 3 seconds delay of Tango timeout. Obviously, we get a timeout here. And the problem was in the server request interceptor, which is a custom code integrated into by Java developers into Tango Java server-side API, and specifically the problem was in this method. Init address get by name something. It's introduced since 1.4, and if we read carefully about it and look into the source code, it's what it does. It makes a DNS call, so it accesses a naming service of the network to get a real name for the API address, which means that for every request to Tango server, you actually make a request to DNS system, and at some points it just says, well, that's enough for me, just wait 5 seconds, I'll come back to you. And you can't predict that, of course. So if you Google for that problem, it's quite well-known thing. Usually they propose to write some ATC hosts, carefully write down all the APIs and everything, but which is obviously not the way we would like to fix it. So I proposed a pull request, where basically we at our Beamlines do not care, and we never use this black box functionality. And yeah, this thing is used only in the black box. So I just put some random constant string there, and we are happy with that. I ran my test, so it's like 1 million requests. It's ran for 6 hours, no timeout, pretty fine. And later on, Gwinnell introduced a fix in the official JTango branch, which basically gets this name, but in a separate process using asynchronous communication, so it's completable future. So eventually it will receive this host name, and it's done only once. So it's kind of acceptable solution. And basically that's the end of the story.
Thank you, Igor. It was extremely interesting for the audience, I think, because we all suffer from this, measuring the time and hunting the timeouts. Is there any questions?
I have a question, if I may.
Yes.
So you were always speaking about Java. So can you characterize this timeout a little bit more? So where is this timeout? Which components are involved? And is there a bug fix with this etc hosts, which may be easily done for us?
Well, as I said, it's always already fixed in the latest version of JTango. So it still gets this address from somewhere, I mean from DNS. It affects every Java server of Tango, built with more or less modern JTango API. I think starting from, if you use something later than Tango 9, then you are affected by this bug because it's introduced. As I said.
Okay, so it's only for Java servers.
Yeah, it's only for Java. I don't know if it's affected in C++, how it's solved there. Might be the same problem actually. And then you also have this in Python because Python is just binding on top of C++.
But to make tests, one could add some host names into etc hosts, you say?
Yeah, if you do not want to dig into the C++ code, there is a possibility to fix it using etc hosts. Yeah. Then you don't need to. Well, depends on how this. Yeah, I think this is implemented the same way because in Java it's basically a native call, which is probably operating system call, and then the C++ probably uses the same. And underneath, it either looks up into the etc hosts, otherwise it uses DNS system. So yes, I think the etc hosts should fix it without changing the code base.
Okay, thank you.
Thank you. So since the time is flying, I opened a breakout room named Benchmarking and Timeouts in such a way you can discuss with